Hello everyone, welcome back to the Network Fixer. Today's video is going to be a bit long, deep, and extremely important for anyone working in networking. Whether you are a student, a network engineer, a data center architect, or someone planning for the future of enterprise and cloud networking. In this video, we are going to talk about EVPN or Ethernet VPN. This is not a quick overview. This is not a certification crash course. This is a complete end-to-end explanation, something you can play in background, listen carefully, and truly understand how modern networks are built today. In this video, we will cover what EVPN actually is, why EVPN was needed, the problems it solves, how it works conceptually, where EVPN is used today, pros and cons, real-world use cases, whether EVPN is still relevant, and finally, the future of EVPN. By the end of this video, EVPN will no longer feel like a buzzword. It will feel logical, necessary, and inevitable. So let's begin. EVPN stands for Ethernet Virtual Private Network. At its core, EVPN is a control plane technology that allows Ethernet layer 2 traffic to be transported across a layer 3 IP network in a scalable and intelligent way. This single sentence already tells us something important. EVPN is not just tunneling. EVPN is not just VLAN extension. EVPN is about control, scale, and modern network design. EVPN uses BGP or Border Gateway Protocol as its control plane. Instead of flooding MAC addresses blindly like traditional layer 2 networks, EVPN advertises MAC addresses, IP addresses, and reachability information using BGP. This changes everything. To understand EVPN, we must first understand what was broken before EVPN existed. In traditional layer 2 networks, classic Ethernet networks rely on VLANs, MAC learning, flooding, spanning tree protocol or STP, and these networks worked until they didn't have problems like spanning tree block links, no active paths, massive broadcast domains, MAC table instability, slow convergence, poor multi-tenant support. As data centers grew, these problems became business risks. VXLAN came in, but VXLAN alone was not enough. VXLAN solved data plane scale, 24-bit VNI instead of 12-bit VLAN, overlay networks, IP underlay, but VXLAN by itself had a big problem. VXLAN had no standard control plane. So vendors used flood and learn, multicast, proprietary controllers. This caused inefficient flooding, operational complexity, vendor lock-in, and this is where EVPN enters the picture. EVPN does not replace VXLAN. EVPN controls VXLAN. Think of it this way. EVPN is the traffic management system. EVPN advertises MAC addresses, advertises IP addresses. It also supports ARP suppression. It enables multi-homing. It enables fast convergence. All using BGP, which is stable, scalable, proven, well understood. Let's simplify how EVPN works. Each switch or router participating in EVPN is called a VTEP or VXLAN tunnel endpoint. Each VTEP or VTEP learns MAC addresses locally, advertises them via BGP EVPN, receives MAC routes from other VTEPs. Instead of flooding, the network already knows who has this MAC. This reduces broadcast traffic, unknown unicast flooding, convergence time. If we consider a high level of EVPN route types, EVPN uses different route types such as MAC or IP routes, inclusive multicast routes, Ethernet segment routes. You don't need to memorize them for now, just remember this: EVPN turns Ethernet learning into routing intelligence. EVPN is not experimental. EVPN is production grade and widely deployed. If we consider modern data centers, leaf spine architectures, active servers, VMware, Hyper-V, KVM, bare metal along with virtual workloads. If we consider multi-tenant environments, cloud providers, hosting providers, enterprises with multiple business units. If we consider campus networks, EVPN is now replacing large VLAN designs, spanning tree. EVPN with VXLAN is becoming common in large campuses, universities, hospitals, and enterprises. If we consider service providers, EVPN is used in metro Ethernet, enterprise VPN services, data center interconnects. Let's talk about advantages. EVPN helps with massive scalability. It can accommodate millions of MAC addresses, thousands of tenants, no VLAN exhaustion. If we consider active, there are no blocked links, better bandwidth utilization, higher availability. In terms of fast convergence, it's a BGP based and updates are gonna be based on the BGP. No STP reconvergence delays. When we consider the flooding, it reduces MAC or IP advertisements. It helps with ARP suppression, cleaner networks. If we consider vendor interoperability, EVPN is an IETF standard supported by Cisco, Juniper, Arista, Nokia, Huawei, Cumulus. If we consider cons and challenges of EVPN, EVPN is very powerful but not perfect. When it comes to the complexity, there is a steep learning curve. There is a separation between control plane and data plane. When it comes to operational skills required, engineers must understand BGP, VXLAN, underlay and overlay. When it comes to troubleshooting, this is the hardest part and it becomes different. No more simple VLAN thinking, it requires structured troubleshooting. When it comes to hardware and software requirements, it requires modern switches. Legacy hardware is often unsupported. Let's be clear, EVPN is used by hyperscalers, used by enterprises, used by service providers. This is not future tech, this is current standard architecture. If you walk into a newly built data center today, there is a very high chance it's running EVPN with VXLAN. If you consider future of EVPN, EVPN is not going away. In fact, EVPN is expanding into campus networks, integrating with SDN controllers, being simplified via automation. It's becoming the default architecture. If you consider future trends, EVPN along with segment routing, EVPN along with cloud networking, EVPN along with zero trust models, intent-based networking on top of EVPN, EVPN will likely be the major layer 2 architecture shift we ever make. EVPN is not about complexity, EVPN is about solving problems the right way. Instead of flooding, guessing, blocking links, now we have intelligence, control, predictability. If you are serious about networking in the next 10 to 15 years, EVPN is not optional knowledge. This was the Network Fixer. If this video helped you understand EVPN clearly, share it with your network team, your students, or anyone confused by modern networking buzzwords. Stay curious, stay relevant, and keep fixing networks the right way. Thank you for watching. You have a great day. Bye-bye.